Assalamu alaikum. So today it is our lecture 5. So we were doing conditional probability. एक दफ़ा रिव्यू कर लेते थोड़ा सा. सो कंडीशनल प्रोबेबिलिटी में हमने कहा था कि हमने किसी इवेंट की प्रोबेबिलिटी फाइंड करनी है गिवन कि कोई और इवेंट जो पहले से अकर हो चुका है. मैथमेटिकली हमारे पास क्या आएगा, प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी डिवाइड बाय प्रोबेबिलिटी ऑफ बी. सो दिस इज़ बेसिक डेफिनेशन ऑफ इट. और मैंने इसमें ये बताया था कि हमारे पास जो है सिनेरी है वो इस तरीके से चेंज हो जाता है कि हमारे पास जो वर्किंग के लिए हमारे पास सैम्पल स्पेस है वो रिड्यूस हो जाती है, एंड दैट रिड्यूस सैम्पल स्पेस इज कॉल्ड द इवेंट बी विच हैज़ ऑलरेडी अकर्ड. सो हम लोगों ने कुछ एग्जांपल्स देखी थी. लेट्स लुक एट few more examples on it. This is example 1.14. It says that roll two fair four-sided dice. Let x1 and x2 denote the number of dots that appear on die 1 and die 2 respectively. Let A be the event x1 is greater than 2. What is probability of A? What is probability of A? Let B denote the event x2 is greater than x1. What is probability of B? What is probability of A given B? So we can define first of all, as we know that we have to define the sample space. So sample space we can define here in in kind of graphical method or some means descriptive method. So we will first draw means it's say graphical method. So that's easy because we have only two dice. So say this denotes the number of dots on first die, and this denotes the number of dots on second die. So it will be 1, 2, 3 because it is four-sided die. So we will have 1, 2, 3, 4. So whenever we toss, we will throw a dice. So they could either have 1, 1, 2, 1, 3, 1, 4, 1, 1, 2, 1, 2, 2, 2, 3. Sorry, 4, 2, 1, 3. 2 3 3 3 4 3, or it could be 1 4 2 4 3 4 or 4 4. So otherwise we can write S is equal to as the same way 1 1 1 2 1 3 1 4 2 1 2 2 2 3 2 4 3 1 3 2 3 3 3 4 4 1 4 2 4 3 4 4. So both ways we can use this, that's not a big deal. So what's the event A? Event A says that x1 is greater than 2. So x1 is greater than 2, so we don't bother about whatever is the x2. So if x1 is greater than 2, so we can see that this is x1, x1 is greater than 2, this portion. So means all those outcomes which are here, that will be the part of this event. So here because all outcomes are equally likely, so n is actually 60. So probability of A, we can write it event from here also, but from here where all the points where x1 is greater than 2, so means this one, these all outcomes. So probability of A would be then because they are 12 over 16. So that is the probability of event A. Now what the event 2 says that x2 is greater than x2, this is here, x2 is greater than x1. So x2 is greater than, here x2 and x1 is both same. Here x2 is greater than, so I will take some other color, so I will circle that. This is 2 1 and 3 1, x2 is greater than 1, x2 is greater than 1. Here x2 x1 is greater, so we will leave it all these row. So here they are equal, and here there's x2 is greater than x1, here also it is greater. Similarly here so until 3 3, so actually this is 3 a bit on the upper side, it's okay. So 3 3 is same, and then it is 4 3, so here we will have nothing in common. So we will have 1 2 3 4 5 and these 6 elements. So probability of B will be then 6 by 16. Okay, so next part says that what is the probability of A given B. So probability of A given B will be then just use some other color. So probability of A intersection B divided by probability of B. So first we need to figure out what's the probability of A intersection B. So from here we have tabular form, we have seen that A intersection B is just these 3 elements. Okay, so here we can visualize it clearly, these are only 3 elements. So the probability then will be, probability of A intersection B will be 3 over 16 divided by probability of B is 6 over 16. So it is 3 over 6, which is 1 over 2. So this is very simple. Let's solve another example. I will just paste it from the book. So it is actually quiz 1.4. So it says that monitor 3 consecutive packets going through an internet router. Classify each one either as video or data. Your observation is sequence of 3 letters, each is either V or T. For example, 3 video packets corresponds to this VVV. The outcomes VVV and DDD each have probability 0.2, whereas each of the other outcomes have probability 0.1. Count the number of video packets NV in the 3 packets you have observed. Describe in words and also calculate the following probabilities. So that is again a very simple problem, but we have to start with defining our sample space. So we have only 3 packets which we are monitoring, consecutive packets, so they could be either VVV, VVD, VDV, VDD, DVV, DVD, DDV, DDD, and their probabilities are already given. Probability of VVV which is equal to probability of probability of same elements, same packets, DDD is equal to 0.2. So probability of all 3 video packets or probability of all 3 data packets is 0.2, which is predefined, and for all of the rest elements here is one, the probability is defined as 0.1. So they have predefined the probability. Now we have to find out these one. So here it's also asks us to describe in words and also calculate the following probabilities. So we will solve A part. Probability of NV is equal to 2. So in description we can write it as the probability of exactly 2 voice packets. The probability of exactly 2 voice 2 video packets. So we should be video packets. So we can find out this event. Probability of NV is equal to 2. That would be 2 video packets, so it will be exactly 2. So VVD, VDV, DVV, that's it. So the probability of each outcome, we know that we just probability of these like this. So probability of each of the outcome is 0.1. So obviously we will just add their probabilities individually, and they will that will come out to be 0.3. Now look at B part. It says that probability of NV is greater than or equal to 1. So in descriptive form we can write it as the probability of at least one video call, one video packet, one video packet. So it means that if we write probability of NV is greater than or equal to 1, that we can write it as probability of, so at least 1 or more than 1, so it will be VVV, VVD, VDV, VDD, DVV, DVD, and DDV. So we will have these elements to find out the probability. So there is another way to find it if we don't want to go for this much mathematics. So we can say that probability, we can write it as probability of NV is greater than or equal to 1, which is equal to 1 minus probability of using one of the properties NV is less than probability is less than 1, or we can write as 1 minus probability of NV is exactly 0. So we know that 1 minus probability of NV exactly 0 is d, and this is 1 minus 0.2, which is 0.8. So the answers will be the same even if we do these all calculations or we do the same method. So these answers will be the same whether we'll come up from here or from here. Next part, it says that what is the conditional probability that we have two video packets given exactly. So how we can write it in description form? The conditional probability of two voice packets of two video packets followed by a data packet given that there were two video packets. So that will be probability of VVD given NV is equal to 2 is equal to probability of intersection of these two events probability of NV is equal to 2. So we know that what is probability of NV is equal to 2. Here we have calculated here. This is 0.3, and if we take the intersection of VVD, so if we take the intersection of VVD with this one, where it is, here it is. So we can see that this is common VVD. Okay, so it means that this is a subset of this one. So it will be straightforward probability of VVD divided by probability of NV is equal to 2, and we know this probability of VVD is 0.1 divided by 0.3, so it is 1 over 3. Now let's look at part D. So part D says that I have to DDV given that NV is equal to 2. Probability of DDV given NV is equal to 2. So here again we will just formulate it. So it will be equal to DDV comma NV is equal to 2, that is the intersection NV is equal to 2. Okay, we forgot to write its description. So The conditional probability of two data packets followed by a voice packet video packet given there were two voice packets. Okay, so this is the relationship. As we can see from their data from the set nv is equal to 2, obviously this is not present there, so there is it is a null set, probability of phi and probability of nv is equal to 2, so it is 0.3, so it is 0. So obviously this event cannot occur for this scenario. So the next part, it says that probability of nv is equal to 2 given nv is greater than or equal to 1. So we can write it in description form. The conditional probability of two data packets video packets or it here exactly two video packets given at least one video packet. So we can write it as probability of nv is equal to 2 intersection with nv is greater than 1 divided by probability of nv is greater than or equal to 1. So if we go back and see the intersection of here, so intersection of these one will be vvd, vdv and dvv. So it means that we will have this one is the subset. So it means that this is exactly probability of nv is equal to 2 because it is the subset of nv is greater than or equal to 1. So we have already calculated these probabilities, so which is 0.3 and this is 0.8. So this is actually 3/8. The next part, and I think so last part, f, it says that probability of greater than or equal to 1 given nv is equal to 2. So in description form we will write it as the conditional probability at least one voice packet given there were exactly two video packets. So we will write it here as nv greater than equal to 1 comma nv is equal to 2 divided by probability of nv is equal to 2. Now again, from the previous part we know that probability that nv is equal to 2 is subset of this nv is greater than or equal to 1, so it means that it will be nv is equal to 2 and probability of nv is equal to 2. So obviously they are same, means which is 0.3 and 0.3, so it is 1. So this is for sure event that if there is one, we know that we have exactly 2, and if this event will occur that more than one video packet will be arrived, so obviously this is a sure event. The next topic that we have, we will not start it with but I will just give a brief introduction so that you can have information on it, so you can read it. So this is actually for so this is partitions and law of total probability. So we know that a partition is you can say operation which divide the sample space into mutually exclusive sets. So obviously that partitions will be used to find the probability of certain events that's been divided into the number of partitions. So I will stop here. I'm not going further into detail of this topic, so we will go through inshallah in next lecture. Hope you are fine, and I hope you will stay safe. Assalamu alaikum wa rahmatullahi wa barakatuh.